For this Fun Fact Friday video, I want to look at what are known as the Pythagorean identities. So these are three trig identities, and I have them over here in green. Okay. These three identities, the most commonly known one is sine squared plus cosine squared equals 1, but you also have tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. Those last two people will sometimes rearrange and give them in different forms, but they all are that same identity. So Pythagorean identity. So what I want to look at is where that name comes from. Why are they called Pythagorean? And it all comes down to the Pythagorean theorem. So the Pythagorean theorem says if I have a right triangle, then the sum of the squares of the lengths of the sides, so let's let our sides be length A and length B, equals the sum of the square of the length of the hypotenuse, which we're calling C. Okay, that's what the Pythagorean theorem says. So that's what we want to mess with to get our identities. All right, here we go. So what I'm going to do, I'm going to divide that whole equation by c squared. So that means I need to divide every piece by c squared. And let's see what that gives us. Well, this first term is a over c quantity squared. The second term is b over c quantity squared. And that last term, c squared over c squared, is just 1. This is actually something we know, okay, but let's look at our triangle to figure it out. Notice that A is opposite of my angle theta. So oftentimes you'll hear people describe that as opposite. Notice that C is my hypotenuse, the length of my hypotenuse to be more specific. And B is the length of the side adjacent to angle theta. Now, you may have learned in trig, our 6 trig functions can all be represented using opposite, adjacent, or hypotenuse. So this A over C, this is opposite over hypotenuse, and that is exactly what it means to be sine of theta. And since it's squared, I'm going to put the square on there. B over C is adjacent over hypotenuse. Well, that's what cosine of theta is. And we'll put the square on there because it's squared. And that equals 1. So there you go. So you can see from the Pythagorean theorem, just dividing by c squared, that length of the hypotenuse c, we get sine squared plus cosine squared equals 1. This will actually work for the other two Pythagorean identities as well. We just need to change which length we divide by. So let's go ahead and divide by b squared and see what happens. If I divide by b squared, then I have a over b quantity squared plus 1 equals c over b quantity squared. Okay, but A is opposite, B is adjacent. Opposite over adjacent is the same thing as tangent of theta. So we get a tangent squared theta plus 1. C over B is hypotenuse over adjacent. Hypotenuse over adjacent is the same thing as secant. And again, we have that square on there. So you can see dividing by b squared gave me my second Pythagorean identity. So now you may be able to guess, to get the third Pythagorean identity, you would need to divide by a squared. And I can leave that as an exercise for you to play with, right? Math is more fun when you play with the math yourself. So divide through by a squared. In that Pythagorean theorem, you will get that third Pythagorean identity. So there you go. That is why these three trig identities are known as Pythagorean identities. They all come from the Pythagorean theorem.